So, well, to relate the topic of recurrence relations and that of induction, let's prove this result. Um, so, how do we do that? Well, let uh, A be a set with n elements, and uh, we will proceed by mathematical induction on n. So we're going to demonstrate that this expression actually determines the number of pairs that we can form from elements of A. So let's begin. Base case. What happens when n is equal to 0? So when n is equal to 0, well, I have that the cardinality of A is 0, so A is empty. And being empty, that implies that the number of pairs that you can form from elements from the empty set is exactly 0. But, well, by definition, that's what we get. So S of 0 is the number of pairs that you can form from A. Now, let's see. Inductive step. Well, suppose that the formula is satisfied for K. For K greater or equal than 0, we're going to demonstrate that it is true for K plus 1. So, let's assume that the cardinality of A is K plus 1. So what this says is that A contains at least one element. So A contains at least one element. So I'm going to write A as this, as A prime union that element that I'm going to call B, just for a moment, right? Where B is not in A prime, right? That's the condition that we need. Well, so once we write it in this form, let's see what we can do. So the cardinality of A prime is equal to K. So this says that the number of pairs from A prime is given by S of K. We're just making use of the inductive hypothesis. Well, after that, let's see. We have to make a correspondence between these two. But let's see. How many pairs are there? Well, the number of pairs